Hey, welcome back. In today's bonus example, we're going to write a program which checks the strength of a password. The program will behave like this. So in the command line, the program asks the user to enter a password. So let's say we enter hello 456 and a capital H. You press enter, you get this output, strong password. So the program checked this password and it returned strong password. So this was a strong password because it fulfilled three conditions. First, it was 8 characters or longer. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 characters in total. The second condition was that the password contained at least 1 digit. This has 3 digits here, so it fulfills the second condition as well. And the third condition is it contains at least 1 uppercase letter. So here we have this big H, capital H, so an uppercase letter. If one of these conditions wouldn't be true, we would get here weak password. So that is a program we're going to write in this video. Everything, of course, starts with getting input from the user. Enter new password. And then we check this password against those 3 conditions. So let's focus on those conditions one by one. Let's think of the first condition, which is the password should be 8 characters or longer. So first of all, you should think, how can you check the number of characters? That you can do with the len function. So if the user enters as a password, for example, hello, len would output 5. So now we can check if the length is equal or greater than 8. So we use a conditional. If len of password is greater or equal than 8, then what do we do if that is the case? So do we print out strong password? No, because we want to print out strong passwords at the end after we check all the 3 conditions. However, you should be very careful here. Logically, these conditions are separate conditions, which means you're not going to write something like if and then elif, and then you check if there is a number in password, and then again you check elif uppercase. So this is not how it works, because these conditions are independent of each other. So we're going to have separate if-else blocks for each of the conditions. So the first block is the block that checks the length of the password, and then we're going to record the result of each condition somewhere. So we're talking about several conditions, and the result of each condition, maybe it should be stored in a list. So let's call this list result. It's going to be empty for now, and then, so let me make some space here, and then if length is greater or equal than 8, so we say result.append true. So the first item of the list is going to be either true or false. So else result.append false. So the first item will represent the first condition, the length condition. So if we print out result and we execute this code, so the user enters hello, we press enter, we get false. So false is inside a list. We run again if the user entered hello, hello, so 2 hellos, which means a long password, and we get true there. Similarly, we're going to add the other conditions in this list, because that's what lists are for. So whenever you want to store multiple things, whatever they are, they could be numbers, they could be strings, they could be Boolean data types such as true or false, which represent these conditions. So whatever they represent, multiple things are stored in a list. So that's the first thing we store in a list. Then we check for the next condition, which is if there is a number inside the string. To check if there is a number inside the string, you do this. So let's say this is a string. .isDigit is a method that strings have, and it returns false or true. But the problem is, see now, if we write a digit inside the string such as 8, and you press enter again, you get false. So it's not as easy as you think, because isDigit actually checks if this entire thing is a digit, not if that string has a digit character inside. So it checks if, for example, 8 is digit, then you get true. If it was A, you get false. If it's 99, you get true, so it's a number. But if at least if there is one letter or other characters that is not a number, we get false. Therefore, the only solution we could think of here is to iterate over passwords characters. So we check every single character, which means if the password is, for example, hello9, we will check first the first H for H in passwords, and we say i.isDigit, and that will check if H is a digit. If it is, it will return true. If it's not, it will return false. So this returns true or false. We want to make use of that, and this is a bit maybe tricky, but not that hard to understand. So if we create a variable here and we'll set it to false, and then here we say if is digit is equal to true. And this is what will happen here. So the interpreter will first run this code. That's another condition, so it will do whatever it does with that. And then it goes in here. Digit is a variable and it will be set to false. So its value is false for now. And then the interpreter iterates over the characters of the passwords. Let's say the first character is H. So the interpreter checks if H is a digit. H is not a digit, therefore this will not be executed because this is evaluated with false. So if H is not a digit, this is false. And since this is false, this is not executed. Otherwise, if when we go to the other characters such as E, O, L, these are also not digits, so this will not be executed. That means digit will stay false. But if there is one character which is a number, let's say at the end there is a number 8, and we say if 8 is digit and that is true, in that case this will be executed. So the value of the digit variable will change to true. If we have more characters in that string after the number, again, for example, for W in passwords, if W is digit, it's not a digit, so this will not be executed. That means the last value that was assigned to digit will remain in place. The last value was true because we had that number before W, and so digit will be equal to true if at least one number exists in the string, in the password. So at the end of this for loop, we're going to have a value for digit which will be either false or true. And then we can check again if digit, and then we exit the for loop. So after the loop ends, then we want to say result.append digit. So digit will be either true or false. Therefore, at this point, result is going to contain two items. So let's try this. Hello 9044, a long password, so we have true for the length, true for the digits. Let's try again. Let's just say hello this time. We have false because it's not long enough, and we have false again because it doesn't have a number. So far it's working well. Next, we want to check if there is at least one uppercase character. The idea here is exactly the same as with isDigit. So when we check a string with isUpper is the method, you get false if the string is not entirely uppercase. So for example, if A and you have B uppercase, you get false. So all the items of the string have to be uppercase. So now we get true because B is the only character there. The result is true. So what we can do is, again, we assign a variable, let's say upper or uppercase. So that is a variable which is set to false. So this is like the hypothesis. logic. When you start to do some research, you want to prove something, then you start with assuming that your hypothesis is false, and then you try to check to prove it. So we assume that the string doesn't have any uppercase characters. Therefore we say for I in password again, if I is upper, so don't confuse upper with is upper. What upper does is it returns a string, which is the uppercase version of that string. And what is upper does is it returns a boolean data type, not a string data type, so false or true. Just wanted to be clear about that. And if is upper, then we change uppercase to true. And finally, we exit the for loop, so you see the indentation level here, and we say result.append an uppercase this time. We run the script. Hello there, 8H. We get true for everything. And finally, how to get that strong password or weak password result instead of this list. So we want to have the output more user-friendly. Either show strong password or weak password. To do that, you can use the all function. All is going to get results as input. So all is a function that see what it returns. So if we say hello, we get false. So all returns false when at least one of the items of the result list is false. Let me print out the result list as well so you see what's going on. So again, hello, false, false, false. This is also false. If at least one of them is true, for example, we have a digit, we have false, true for digit, false for uppercase, but the result is again false. So this is again considered a weak password. If everything is strong and tidy like that, lots of numbers, uppercase letters, and then we get true. So the all function returns true when all the items of the list are true booleans. Now we can make use of that and say if all result is equal to true, print strong password, print else, print weak password. Let's make a break line in here. We have this suggestion here by PyCharm, but we will fix that in just a bit. So if we run the script again, hello, uppercase letters and numbers as well. So this is a strong password, therefore we get strong password here because this is equal to true. If the password was short, no uppercase letters, no digits, we would get weak password as a result. So you can remove that print result if you like, and you get only that output, so more cleaner. Now we can fix this here. So if you roll over your cursor, this says that expression can be simplified, which is true. So the way you can simplify this is by just removing that. So that is equivalent to that. When you say if all result, what you mean is that all result is actually true. So Python is simplifying that by allowing you to not have to type is equal to true. And that is the suggested way to do it. Now I don't want to close the video here because I want to introduce you to a new data type, dictionaries. What are dictionaries? Well, dictionaries are somehow similar to lists, but also very different. So result is a list in our program, and it looks like this. So it's a list of booleans in this case. The problem with lists is that sometimes you want to know what each of these represents. So we want to know that false represents the length condition, true represents the digit existence condition, and false represent the uppercase condition. You know, that is different from, let's say, when you have a list of temperatures and all the temperatures are not needed to be associated with something because it's just a series of temperatures. But here we might need to know what's going on more as a programmer. In that case, what we want to do is we want to use a dictionary dictionary. So result is equal to a list here with square brackets, but to create a dictionary you use curly brackets. And then once I did that, you see here this append method is highlighted because a dictionary doesn't have an append method. So if you open the Python console, if you check for dir list, you see that somewhere in here we have the append method. But for dictionaries, if you do list dict, so dict is the type that represents dictionaries. Sorry, not list dict, but dir dict. So I meant to show you the methods associated with dictionaries. So you'll see that the append method is not part of dictionaries. So how do we add items to a dictionary? Well, let me show that to you. Again, a list looks like this when it's empty, and if it does have some items, then it will look something like, let's say it has numbers 14, 20, 30. And a dictionary uses curly brackets and it is divided by commas, so its items are also divided by commas, but then it doesn't have single numbers, but it does have these so-called keys. So height 14, width 20, and depth 30. So we have 3 items, 1 here, 2, and 3. Actually, the last comma we don't need it, so 3 items, 2 commas. Same for list, 3 items, 2 commas. So a dictionary, the items of the dictionary are compound. They are made of a key, so that is the key. It is a string in this case, and that is the value. And the key and the value are divided by this column. So that's one item, a key value pair, and that's the second item, key value pair again, and then the third item. So you press enter and B is a dictionary now. You see the difference here? So a dictionary could be more useful when the data are different from each other. So this is the height and this represents the width and this represents the depth. So there is a need to know what each of these values are. And that is what dictionaries are for. Now, to help you understand the difference between lists and dictionaries better, I'll make an example from the physical world. Let's suppose we are in this cafe and the barista has these 2 shelves. On the left and on the right. On the left, the barista has a series of jars of different sizes, glass jars, and they all have sugar. Some jars have more, some others have less. Then on the right side, there's another shelf where the barista has these jars, but they all have different things inside. So one jar has sugar, the other has salt, another one has coffee, another jar has butter. No, the jars of this second shelf is better to be labeled, because these are different items. On the left side shelf, this is not necessary because you know that all these are jars with sugar. So it's enough to just have like a label on the shelf, which could be the variable of this list of sugar jars. So when you have a list of similar items, then you don't need to name each item. But when you have a list of different items, then this list is better to be a dictionary. So a dictionary where each item is labeled. I hope that makes sense. So that's the difference between lists and dictionaries, and the other difference is the way you access items. So for a list, you just say, give me the item with index 1, and it gives you 20. So that. For dictionaries, you do the same thing, but instead of indexes, you specify, guess it, the key. So B, square brackets, just like we have with lists, square brackets, and then you write down the string representing the key for the value you want to get. So B width will give you the value of width. With that in mind, let's go back to our code. So result is an empty dictionary now, and we want to populate it with values. So to populate a dictionary with values, you don't use append as we did with lists, but you do the same syntax. So let's say we want to add a new item here, B area, and that is equal to 100. Let it be a number. and then you say B, and you see that area has been added as a value, so key and value as an item of the dictionary. So we can do the same thing here. We say result. Let's write a key name for this, so let it be the length. So the length will be equal to true. Else, we do the same. So I'm copying that here, but this will be false. And then for digits, result. Currently we append this, but now we want to append false or true to digits, maybe a string called digits. So that is equal to the variable digit. So again, we are adding keys and values. Here we add the key length, which is equal to either true or false, depending on which of these will be executed. And then we add another key value pair. The key is digits, the value is the value of this variable, which is either false or true. And then again here, result. Let's say uppercase, just like that, is equal to uppercase, which is again true or false. So let's see what we get. Run the script, enter hello 9, and that's what we get from this print function. So that prints out the result dictionary. Length is the key of this first item. So that's the first item. The key length, and false is the value of that item because the length was not greater or equal than 8. Therefore, this was executed. And then digits is true because we have this number. And uppercase, the key here, is false. So now we have a better view of the data structure. This is an improvement from the list data structure because we also see the associated descriptions of each of these values. So this helps us as a programmer maintain the program better. The user, though, will want to see either strong password or weak password at the end. Now, I know you're thinking, why do we get strong password here? Well, that is because this looks at the keys of the dictionary. So, if you want to check the truthness of the values, you want to apply the .values method here. What that does is this. So, let's say B is the dictionary, right? In here, results is the dictionary. In our console, B is the dictionary. So, if you say B.values, what you get is only the values of the dictionary. So this is like a list type of object. It's called a dict value object, but it resembles a list. So it has the same structure as a list. And if we run the script now and we say hello 9 again, then we get weak password because this time this all is checking the values of this dictionary, which if you want to see them, you can say result.values. So hello 9, we get the dictionary, the full dictionary, and then we get the dict values print here from this line, and then we get weak passwords because at least one of these values is false, so not all of them are true. And that's about dictionaries. So you should use them whenever you want to know what each of the data is about. And this is usually the case when the data inside your sequence, which could be a list or dictionary, are needed to be known to you as a programmer what they are. So it's easier for you to understand the data, to read the code. So think of the keys of the dictionary as metadata of the values. The values are the central points of the dictionary, of course. So you want to store your data in the values, but the keys are some additional data, so-called metadata. So thanks a lot for following this long video, but lots of good information that will help you go forward with the course. So thanks a lot and see you later.